This simulation is going to help us to understand the different states of matter. Well, three of the states of matter. And first, imagine that this is a container with ice at the bottom here. So this whole kind of aqua colored region that represents frozen water or ice. So this is in a solid state. So here what you notice is that even though the water is frozen, there's still vibration here. Because the temperature of this ice is not at 0 kelvins, it still has some temperature, so it has some kind of motion. But still, these water molecules, they're stuck next to each other. They can't really go very far. So this is going to represent a solid. So there's also vibration, but it's not that much vibration. So let's see what happens next if we add heat and we start to melt the solid and we turn into a liquid. So when you turn to a liquid, you add heat to it, so you break some of the bonds. And what you notice is that those same water molecules, they can move back and forth, and they move faster. So the reason they move faster is because they're at a higher temperature. So, but all the bonds, so they're not completely broken. So now you have water molecules that are bouncing around. And if we add more heat, then we can break all of the bonds. And there, this is going to represent water vapor, where all the bonds are broken, and the water molecules can move freely throughout this entire container, and they move the fastest. So in terms of temperature and motion, let's look at this again here. So a gas is going to have a high temperature because the water molecules move very fast. And once you start to cool this down, they start to form a liquid, and there they move more slowly, so they're at a lower temperature. And you can cool it down even more and turn it into a solid. So there, they barely move at all. So they're at the lowest or the coldest temperature. So those are the three states of matter, and you're looking at them on a molecular and atomic scale.